Hello again. We are going to finish up section 2, or at least start section 2, chapter 20. This is exactly where we ended before talking about stability. We talked about hydrogen being the exception to the rule, and it needs actually 2 electrons to be actually filled and content and totally stable. And then helium is already filled with 2, and so hydrogen tries to take on the dot diagram of helium, which is with the 2 outer electrons. Again, for any of these elements to be stable, they need to either gain, lose, or share electrons in order to be very, very stable. We're talking about those outermost energy level electrons. In section 2, we're going to start talking about, and we have already, ionic bonds. If you guys remember, please don't forget to have your periodic chart out in front of you throughout all of this. When we talk about ionic bonds, we're talking about gaining or losing electrons. Remember, it's a metal and a non-metal that we're talking about combining here. Let me get my pen going here. A little slow with this, sorry. So ionic bonds gain or lose electrons. They form what we call an ion, which are charged atoms here. For some reason the ink is not working. I will get it going here. There we go. Remember, metal plus a non-metal is an ionic bond, okay? When we're talking about ions, they definitely are charged. Okay. In other words, the electrons, they don't equal the protons. Remember, at the beginning, we talked about all the elements on the periodic chart, assuming that they were neutral. In other words, the same number of protons and electrons. But if something loses or gains an electron, obviously it becomes more positive or more negative. I've drawn this for you before. If by chance, okay, it looks like I have to do the pen each time. I'm going to have to figure that one out. If an atom, say this is an atom, very neutral, same number of protons and same number of electrons. If one loses an electron, it is now more what? Positive. If I have an atom, assuming it's neutral, and say this atom gains an electron, it is now more negative. So we're saying here, if anything loses an electron, it becomes positive. If an atom gains an electron, it becomes negative. Negatively charged, positively charged. Okay? We talk about these outermost, the electrons in the outermost energy level as being valence electrons. You've heard me use that term before. I will probably be using it a lot from here on out. Your groups 1 through 3, right here. Here we go with this pen again. Why does it do that? They tend to lose electrons, groups 1 through 3. Groups 5 through 7 tend to gain electrons, and groups 4, or group 4, now they'll either gain or lose electrons. So they kind of go both ways. And then our group 8, oh my goodness, I am so sorry. I have a feeling I'll be saying this every time I'm doing this. I will try to figure it out. Group 8 has 8 valence electrons, or 8 electrons in the outermost energy level. No reaction. They don't do anything. Remember, they're completely filled and happy. So once again, we've got our groups 1 through 3. They tend to lose electrons, or we know it as our alkali, alkaline, and our transition elements. They have 3 valence electrons, electrons in their outermost energy level, and they do tend to lose those. Our groups 5 through 7, they have 5 through 7 electrons in their outermost energy level. They will tend to gain electrons in order to become totally stable and happy. Okay. Group 4, which has 4 electrons in its outermost energy level, they will gain or lose. And once again, group 8 has 8 electrons in its outermost energy level, known as valence electrons. They won't do anything. No reaction at all whatsoever. So a little bit of a review there. We have gone over that already. I've already told you we're going to be talking about oxidation states. If you look at your periodic chart and see the key at the top where it says atomic charge, It actually gives you carbon up there. That is the charge of that particular atom. These are found, again, on the periodic chart. It's not a secret. It gives the ion of the element. In other words, the charge of the element. If you look at group 1, which I'm pointing out here, 1 has a positive charge. Group 2 has a +2 charge. Now, when I say you're looking at that periodic chart, you're looking at that atomic charge on those elements of group 1. If you notice, all the elements in group 1 have a +1. All the elements, so this is group 1, this is group 2, have a +2. In other words, group 1, they're going to tend to lose 1 electron, making it more positive. Group 2, they tend to lose 2 electrons, making it a positive charge. Remember, anytime an element loses electrons, it becomes more positive. We'll keep going here. Groups 3 through 12, I've told you this before, they do tend to lose 2 electrons also, but they may have other options. We probably won't be going into many of those other options, so up to this point through the rest of this chapter, we'll know groups 3 through 12 as losing 2 electrons and having that +2 charge, okay? Groups 13, they tend to lose 3 electrons. We have group 14. They will either, remember, lose or gain 4 electrons. Group 15, they tend to gain 3 electrons, noting the negative charge there because it's gaining 3 electrons. And then we have group 16, tends to gain 2 electrons. Again, the goal of all these guys, they want 8 electrons in that outermost energy level. Okay? In order to do this, this is what they're going to have to do in gaining or losing these electrons. Group 17 will gain 1, and group 8, absolutely nothing. Because why? Because they're very stable. Remember, very, 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 very stable. Again, just to go over that stability, when the atom's outer energy level is complete, it is very, very stable. And only at that time are they like the most stable. Hydrogen and helium are stable with 2 electrons, and the rest are all stable with 8 electrons, okay? So we do refer, again, these numbers here that I just went over, all these as oxidation states. So if I were to say, look at an element, and I say, look at iron, please, it's actually atomic number 26 on your periodic chart, and I asked you, what is the oxidation state of iron? I will always say, go with that top atomic charge. If you look at your periodic chart, iron, make sure my pen is working. Iron on your periodic chart has a +2 and a +3. This is what it looks like on your periodic chart. I always want you to go with that top oxidation state. In other words, atomic charge. But we're calling these oxidation states. So please keep that in mind. Always go with the top oxidation state when looking at these, okay? See if I can add anything here. I don't think so. Let's talk a little bit more about ionic compounds. Again, so that you have this, in your notes, an ionic compound is a metal and a nonmetal. You certainly should know that by now. We've talked about that numerous times. There is that transfer of electrons, either losing or gaining, okay? And these ions combine to form, in the end, a neutral compound. When we talk about the sum of the charges, when we add them all together, they will be 0, okay? Compounds, in general, are neutral, okay? It's always a cation that's always named first. Your cation is your plus. Oh my goodness, I am struggling with this one. Cation, anion. The cation's always named first before the anion, and that will make more sense hopefully soon here, okay? We talk about crystal compounds. We talk about the stability of these ionic compounds. Your ionic compounds, there are a lot of crystal compounds. They are very stable, is what I'm trying to say here, and they do have very high melting points, okay? Again, they will either lose or gain electrons in an ionic bond. Let's go over a few dot diagrams of these, and hopefully they'll make a little bit more sense to you. So say we have magnesium and chlorine. I want you to look at the oxidation state of magnesium. Magnesium, find magnesium on the periodic chart, it is number 12. Magnesium actually has an oxidation state of 2. And chlorine actually has an oxidation state of 1. That is the top charge on that chlorine on your periodic chart. Again, go with that top atomic charge, which we will call oxidation state. When these combine, that magnesium is actually going to lose those 2 electrons. The dot diagram, magnesium looks like this. 2 electrons in the outermost energy level. In order to write magnesium, I'm kind of skipping ahead here, but I need to show you this. And as I keep showing these to you and explaining it, it should make more sense. When these guys combine, they actually switch their oxidation states. So when I write magnesium chloride, it's going to look like this. The 1 for the chlorine actually comes here, but remember we don't write 1, we omit the 1. And the 2 now comes here. So it's magnesium chloride. So this is telling you there's 1 magnesium, electron dot for magnesium, 2 electrons in the outermost energy level. Electron dot for chlorine, see there's 2 chlorine by that 2 right there. We have, chlorine has 7 electrons in the outermost energy level. Just quickly draw these here. This electron will be lost to chlorine there. This one will actually be lost to chlorine right there, making them now all very, very, very stable. Just to give you an idea. Let's try another one. Here we have potassium and bromine. Potassium is atomic number 19 on the periodic chart. It has an oxidation state of 1. Bromine, atomic number 35, has an oxidation state of 1. Now, if these 2 numbers switch, that will give me 2 1s. They would cancel each other out. You don't put the 1s there. 1 are telling you that there's 1 potassium, 1 bromine. We're good. Electron dot for that, we know that potassium has 1 electron in its outermost energy level. We know bromine has 7 electrons in its outermost energy level. This will now come here. It will lose its electron to bromine. Very stable, very happy. Barium plus nitrogen. Now, barium has an oxidation state. Again, look at that atomic charge of what? 2. See the plus 2 there? Next, we're not going to worry about the plus or minus right now. 2, right there. Nitrogen has an oxidation state. Look at that top oxidation state, okay? What is that top oxidation state of nitrogen? It is 3. I'm going to put the 3 here. The oxidation states switch. And how do I write that? Ba3 and 2. That's all they're doing. Those oxidation states are switching. Always go with that top oxidation state. In order to do the diagram for that, we know that barium has 2 electrons in its outermost energy level. We know that there are 3 of them. Right here, 3 of them. There are 2 nitrogen. Now nitrogen has 5 electrons in its outermost energy level. Okay, now when these guys transfer, these are all going